Alright, hey Veronica, there's going to be a little noise in the background here, but I wanted to get this done for you so I could show you a little bit about domain and range. So on here, what I did is I put in a parabola here, y equals x squared, you can see that. I put a point here, A, on this parabola. What I want to illustrate is domain and range, and this is what I did for the class. So just bear with me for a second here. I got to set this up a little bit, and then we'll have it. So it just takes a few minutes for me to get it. That was on the wrong, for some reason it was on the wrong thing here, so there we go. Of course it went a lot faster there we go. So what this does here is this moves this point along here, and what I'm going to do is put a point on intersection down here, right there, and a point here. Okay, and then I'm going to trace these points so you can see what that does. There we go, and I'm going to trace this point. Okay, so now what this is that the A, you can hear that, I'm sure. The A represents the point on a parabola. B is input, or x's. That's our domain. So our domain is down here. Our range is over here. That's our y's. So as I slide this along, you can see that it traces along that whole axis there, right? But on the other hand, oops, let me zoom out a little bit more. Try this again so you can kind of see. My Surface Pro does not work extremely well with GeoGebra. What I wanted to show you was that this whole thing down here on the bottom, the x-axis, will get completely covered because that parabola just continues to extend. But the range is only greater than 0, right? It's equal to 0. You can see it comes down here at 0, but it's only greater than 0. So the range is always the output. The domain is always the input. Domain is x's, ranges is y's. As I type this in here, I get this kind of a deal where you can kind of see. And again, it's going to cover everything. If I move this up just a little bit more, you can see that it's going to continue to go, and even in both directions. So we'd say the domain is all real numbers. So I'm going to turn this off here and eliminate that point. There we go. And as soon as I go like that, my trace is gone. So now what I'm going to do is put in this one, all right, and do pretty much the same thing. All right, I'm going to put a point here on this object, but I got to get it right on or else it doesn't work. Okay, and then I'm going to draw some perpendiculars down, just like I did before, to show you the domain and the range. There it is. And yeah, we know that. And here. Okay. Alright, now I'm going to trace those points just like I did before to give you an idea of what it looks like for domain and range. Okay, so now I'm going to move this, and we can see that the domain is going to go there, and so is the range. And we're going to keep going and going and going and going and going, right? But in this case, the domain down here on the x-axis is greater than or equal to 0, and so is the range. Okay, it's greater than or equal to 0. This curve is going to continue to extend upward, which means that range is going to continue to expand upward in this direction. Okay, so here, this is going to go up that way, this is going to go that way, but nothing's going to happen down here, right, or down here. Okay, so that doesn't work either way. All right, let's do one more here. Oh, hang on. All right, so that's how that works. Now let me finish this up for you. All right, I'm going to get rid of this one now and get rid of this, all this stuff that I wrote. There we go. And I don't need this point anymore. Where'd that end up at? Oops. Okay, there we go. Good. All right, now let me put in this one here because this one is a little different. So we'll put that point on there. Okay. And again, we're going to draw some perpendicular lines from here down to this guy. Oh, man. There we go. Okay. Now here I can move this, right? So what I'm going to do is set up a trace on this point. Set up a trace on that point. Okay, this one's going to be a little harder to see, but we're going to move it. So you can kind of goes along there. It's getting really, really close. Right, and it comes way up this way. And you're going, what the heck's going on with this guy? Right, what's going on with this? Now, I didn't get a point over here, but if I did, okay, you would see, and it's really hard to see this, but let me see if I can get this zoomed in just right. And just right over here. What's happening is that it never gets to 0 on the domain part. Okay. And in actuality, it never gets to 0 on the range part. You can see it getting very, very close to 0, but not quite. Even if I did it over on this side, that wouldn't work. So the reason for that is because it was a function 1 over x. And 1 over x, okay, you can't have 0 on the bottom of a fraction. So the domain would be, cannot be 0. All right, so let me go back into here and do this real quick. So if we have a function 1 over x, x cannot be 0 because you cannot divide by 0. So you don't need to actually graph that one to know what the domain is. Okay, x cannot be 0. All right, same thing with the range. You can graph it, all right? But if you know that, wait a second, I can't have 0 down here in the bottom, then I know that that's what the domain cannot be. Same thing with that square root function. Say I have an x squared plus 1, all right? And I know that I can't have a negative underneath here. I can't take the square root of a negative. So that means that x, let's just go, has to be greater than or equal to 0. So then I could subtract 1. There's my domain right there. Okay. The range is the same thing as any square root pretty much. Y has got to be greater than or equal to 0. Okay, you're not going to get a negative out of that square root because you can't take the negative of it. All right. So most of the time, those are going to be the ones that are going to be different. An x squared, okay, a y equals x squared of any point. It's going to be domain of all reals. Okay, any line, y equals 3x plus 4. Domain is going to be all reals because there isn't anything that we can put in there for x that's going to cause us an issue. All right. You know, in Desmos, you can graph them, but sometimes it's just easier to look at them too. Okay, we really didn't do much. We pretty much graphed them because I told the class we didn't have to worry too much about x plus 1s or 1 over x's and stuff because they do those later. And I wanted to get people used to Desmos, but anyway, I thought I'd show that to you and share that. So what I'm going to do is pause this and send it to you and hope this helps you.